In this video, I will introduce you to the Chipster software for bioinformatics data analysis. You will learn what Chipster is, how the user interface works, how to import data, how to store and share your analysis with a colleague, how you can make your analysis faster, how to get help, and where you can find training materials. So Chipster is a user-friendly analysis software for high-throughput data. It contains over 500 analysis tools for different kinds of data, for example, single-cell RNA-seq and spatially resolved transcriptomics from the Visium platform. The tools can be either command-line tools or they can be based on R bioconductor packages. For example, the tools for these data types are based on the Seurat R package. Chipster is free and it's open source. It has certain useful features. For example, you can share your analysis sessions with a colleague and the analysis metadata is tracked. So Chipster remembers for each file which input file you used, which analysis tool, and which parameter settings. We have a lot of training resources available. For example, there are lecture videos, exercises, and Chipster server has several training datasets. If you are a Finnish user, you can access Chipster with your university or research institute account, meaning Haka or Virtu or CSC account. And for others, we can open guest accounts, and we also have training accounts available. Technically, Chipster is Angular-based web app, and the actual analysis tools run in the cloud. So this is what Chipster front page looks like. This is where you launch the software. And you can also find useful information here. So, for example, links to our upcoming courses. There is a link to the tutorial videos and the course material that I mentioned. Chipster user interface looks like this. So here I have been doing some bulk RNA-seq data analysis. I have 2 samples, paired FASTQ files. I have been doing alignment, counting reads per genes, and doing some statistical testing. Now each file is shown as a colored box, and the color refers to the analysis tool category that produced the file. So for example, the alignment results are red because the alignment category is red. Here you can see only the file name extensions, but when you mouse over the file in Chipster, you can see the file name, and you can also list all the file names if you click on this list button here. The whole point of this, what we call a workflow view, is that it allows you to track the relationships of the file. So you remember what input file you use to produce a certain file. Now the analysis tools live on this side. First of all, they are grouped into tool sets. So now we are in the next generation sequencing tool set. And under that, we have these tool categories. If you click a category, you will see the tools in that category. And when you select a tool, you will see a little description of that tool. But if you click more info, that will take you to the actual manual page for that particular tool. So when you want to run analysis, you select input files, category, tool, and you can either click run or you go to the parameters and set the parameters according to your input data and then click run. And when the job is ready, the result files will appear here as new boxes, and you can select them and view them either in Chipster or you can open them in a separate tab. When no file is selected, like now, down here you see information about this particular analysis session. So you can write notes for yourself for each session. Here is a different session. This is spatially resolved transcriptomics data. So you can see that there are quite many analysis tools for this kind of data. Typically the result files, so they are R objects, but also images as PDF files. So those you can visualize either here or you can open them in a new tab. If you are familiar with this kind of data, you can recognize these images. So these ones are for single cell, and this is for spatial transcriptomics. So essentially, they are the same that you would produce directly in R if you were working using RStudio, for example. How do you import data to Chipster? Well, you can obviously upload data from your own computer, either files or whole folders, or you can bring data from a URL from internet. If you have a whole session that somebody gave you, you can import that session. And typically people would actually share sessions within Chipster, so there is no need to take them out and back in again. And you can also import data from public databases. When you do your analysis, your results are saved automatically in the cloud. Not only the files are saved, but also information about their relationships and metadata. So what tool and parameters did you use to produce a particular file? It is important to note that Chipster is not a storage place, so these cloud sessions are not stored forever, and we encourage you to download your session to your computer or elsewhere when you are ready with your analysis. As I mentioned earlier, you can share sessions with other Chipster users. You can either give them view-only access, or you can give them full rights to your session. Importantly, if your analysis job takes a long time, you don't need to wait. You just ensure that the data transfer has completed, so the data is on the Chipster server, and then you can close Chipster. When you come back later, like the next day, the results files will be there. How to make your analysis faster? Well, first of all, you can run many analysis jobs at the same time, so you don't need to wait that one finishes before starting a new one. Then the Run button that I mentioned earlier actually gives you several options if you have selected several files. You can either, if you have one file, you can run the job for that. If you had several, you could, with one click, run the same analysis for all of these files. Or if you have paired and FASTQ files, you can, prior to the analysis, you can pair them to samples, which I will show you briefly. And then you can run the tool for each of your samples. So with one click, all the samples will be analyzed. And let's have a look how you pair FASTQ files. So there is a function called define sample files. It could be also pair sample files. And here, so these are my files. I have two pairs here. I click find pairs and it pairs them this way. Then you save this, and when you come to run the tool, so here I have selected those FASTQ files. I want to use the HiSet aligner, and now I have the option run tool for each sample. So this can be handy if you have many samples. Sometimes you bump into a problem, and then you can send us a support request directly from Chipster. Now, this is handy because it automatically includes the error message that you received. And optionally, you can also give us a link to your analysis session by ticking here. So if you do that, then we get an encrypted link. We can open the analysis session and view it exactly the same way as you can see it, which is very helpful when troubleshooting, so we can see what has possibly gone wrong. So to finish with, these are the important links, so you can email us anytime if you have any questions or suggestions for new tools, for example. This is the website. Here you find the training materials, and here is our YouTube channel. So we have almost 170 tutorial videos there about different topics. They are grouped into playlists. So for example, we have tutorial videos regarding single cell and spatial analysis, and also for microbiome community analysis.